What's up guys, so today we finally have a video about how to install this Picofly chip inside of the OLED console. Again, the main reason I'm sharing this is because it has a lot of implications for repair, and I think that the anti-repair measures that companies go to make their consoles unrepairable is ridiculous, and I want to combat that as much as possible. I am not at all responsible for how you use this video in any way, shape, or form. I am not responsible for you breaking your console by trying this. Please do not let this be your first soldering project. I cannot stress that enough. The amount of destroyed and demolished OLED consoles and the ghastly things I have seen done to these poor consoles is absurd. But if you decide to not heed my warning and try this anyways and break your console, there is a repair link in the description. I have a lot of experience with repairing Switch consoles in particular, especially failed installation attempts of these chips. So please feel free to make use of that. The installation process for the OLED console is significantly more difficult than the Lite and the V1 and V2 consoles. I'm going to be going over the Kamikaze method with this console, but I also have a clip of another console where I install something called the DAT0 adapter instead of digging into the motherboard. So I'm going to be showing you both methods in this video in complete detail, and we're going to be talking about the difference between the two methods and which one is right for you. First thing I'm going to go over is tools that you're going to need in order to do this installation. Full disclosure, I'm going to have affiliate links for all of these tools that I'm using in the description in case you are missing a few of them and want to pick them up and support the channel. We'll take a look at the actual Picofly right after this. We're going to need to replace the thermal paste. I use Arctic MX4. Buy your thermal paste from a reputable source. Don't buy this stuff from AliExpress. The AliExpress stuff is fake and does not cool nearly as well. You're going to need some flush cutters or precision cutters like this. The sharper you can find them, the better. I really like these Hakko cutters. They're super great. I'll also be covering the software setup portion of things in this video. So if you want to follow along with that, you're going to need a SD card. Grab a name brand SD card from a trusted source. There are plenty of fake ones, even on Amazon and all over Marketplace and things like that. You're also going to need a SD card reader. You're going to need either a Y000 or Y00 screwdriver. Both will function fine. The Phillips screwdriver is going to be the one I'm going to be more picky about here. Definitely get yourself a Phillips 000. This is the best fitting screwdriver for the job. If you use anything bigger or smaller than this, it's very easy to strip the Phillips head screws, especially on the Joy-Con rail and on the metal cover. You're going to need a really nice sharp pair of tweezers, as sharp as you possibly can get it, because we're going to be scraping back a really tiny trace with these. So make sure it's super sharp. Again, I'll have a link for these in the description if you need ones that are this sharp. Get yourself a sewing needle, like a nice tiny sewing needle, the tiniest one you can find. We're going to be using this to take off the APU cover, and don't bend up your nice tweezers. We're also going to need some Kapton tape and some double-sided tape. I like to cut these with ceramic scissors, but you can use whichever scissors you want. One thing I forgot to mention was these plastic spudgers that I really like to use. You don't have to have one of these, just something thin and plastic that you can stick in between here and here. And obviously you'll need a soldering iron, and I highly recommend getting a tip that you're comfortable with soldering tiny points on the motherboard. So we're going to be needing to solder to some pretty small points. I swap between these two a lot. I really like the knife tip quite a lot, especially for installing the APU flex. And it's always nice having a bent conical tip like this that is very precise. So just make sure you have some nice precision tips. Don't try to use some like half broken rusty soldering iron tip that plugs directly into the wall. Get a nice soldering iron with tiny tips like this. You'll also obviously need stuff to clean like alcohol and Q-tips and wipes, along with solder and some wick if you mess up, and of course flux. We're also going to need some enameled wire. I'm using 30 gauge. This red stuff here, this is a good size for what we're going to be doing. You're also going to want a nice like stiff cleaning brush to be able to clean the APU, because we're going to be soldering to the APU. And we'll also need a multimeter. If you don't already have that and the cleaning supplies and solder and things, you probably shouldn't be attempting this installation. But if you want recommendations for those types of tools, you can check out, again, my tool video that I'll link down in the description. So that's all the stuff that you'll need for the installation if you are going to install with the DAT0 adapter. If you want to do the Kamikaze method, you're going to need a few additional things. You're going to need a grinding pen. I recommend this Ant D2 grinding pen with the sharpest tip on it. You're also going to need some solder mask. I really like the Mechanic UV solder mask. Mechanic also makes a nice curing lamp, and you need a high-powered one to cure the solder mask well, so that's a good one. And you also need a little bit of leaded solder paste, the 6337 solder paste, which melts at 183 Celsius. this is the stuff you want. So again, these tools are only if you are going to be doing the Kamikaze method. This is going to be somewhat of a lengthy video, so I'm going to be breaking the video up into sections, which I'll have listed in a comment below the video that you can quickly jump to in order to go to the part that you want to reference. There's quite a lot of stuff to cover here with the installation, the tools, and the software setup, so I just want to make sure it's easy for you guys to jump around and get what you need from this video. So without further ado, I'm going to get this whole area cleaned up, and we're going to take a look at the Picofly chip itself, and we'll start the installation process. So the first thing we're going to be looking at is the chip. I'll have a link for where you can grab this particular chip in the description. So this is the one you want for the OLED console. So here's the OLED console itself. I highly recommend, if you don't have a screen protector on the console, to get a bit of soft felt paper like this or something to go underneath the console while you're taking it apart. You don't want to be scratching up the screen with some like solder balls or leftover wire, and it's always nice to just protect the screen of the console. All right, so now that we have the motherboard out, we're just going to go under the microscope, and here's where we're going to get our sewing needle, and we just want to stick it right in the corner of the lock here and pull out. You don't need to press down into the lock too much. You don't want to risk slipping and cutting through traces that are beneath the shielding. You can see, especially on this one here, there's tons of little traces here. So you don't need to put any actual like downward pressure, just outwards pressure like this, and you just need to clear it from the lock right here. There's no need to pry up on this or anything. I highly recommend doing it this way. I've seen a lot of these consoles damaged solely because people tried to rip off the shielding with like pliers and tweezers and stuff like that, and you really don't need any of that. You just need a needle like this. This is the best way to get this thing off. So that is perfect, just like that. All of those locks are undone. You're just gonna get your fingernail on the top corner right there and pull up. You can also use a plastic spudger for this if you want. And once the top 3 corners are undone, you can kind of peel up like this from the thermal paste between the shield and the APU, and the thing will just come off perfectly like that. So we'll clean this in a second. First, we're going to clean the shield here. A dry Q-tip just to take the bulk of the thermal paste off. And then for the rest of that, what I like to do is take a Q-tip covered in alcohol and just do circular motions like this all over the center of the shield. Just gonna grab another Q-tip and keep going. And this does a great job of cleaning the inside. Just keep rotating the Q-tip so it's fully being used, so you're not just using one side of it. And then we can finally take a dry Q-tip and just kind of mop up what's there. Perfect. So we have this nicely cleaned shield here. So before we put the shield aside, I'm just gonna take the end of the brush here and just bend these sort of clips back in. I just want to flatten it out just like that. And we're just going to go around and keep flattening out all of the little locks here, just so that this clips nicely back into place when we put it back on. So that's perfect. We're going to put this aside now, but we'll modify it a bit later, but I'll show you that when it comes time. Now we're just going to clean up the APU. Again, dry Q-tip. We're going to get as much of this off as we can. Just go on either side of the row of capacitors on each side of this thing, just like this, to get as much off as we can. You can really get a lot without alcohol like this. You can see it just kind of clumps up all together, and it makes it much easier to take off. But once it looks like this, we're gonna take a brush. I use one like this, and I'm gonna drench it in some alcohol. And you want to clean in the direction of the capacitors to get the thermal paste out from in between them, because we're going to have to solder to these caps here. So if you just go in like circular motions right above the caps, it's the best way to get those cleaned. And I'm going to take a Kim wipe and just kind of soak up the thermal paste here. One more time, mix in alcohol and then soak up the thermal paste. And you can see that's cleaned up the APU real nice. So I'll have a link for this in the description, but this is a really nice guide just to walk you through the various points on the various consoles. And while this is primarily for using the actual RP2040 chip, it's still a nice reference for where all these points are on the various motherboards. And it also goes through the error codes for the Picofly that would happen if you did a poor installation or if the console is broken in some way. So I just wanted to point out this guide because this is the essence of how this chip works and where the points on the motherboard that we're going to be soldering to are for the OLED console. So for the clock point or the D point on the motherboard on the OLED, we need to cut the frame right above the APU right here. So I find it's easiest to cut here and here. Some people like to cut in the middle here. It really doesn't matter as long as you get the frame off on this area. One thing I will say is that it's very easy to accidentally snip the corner of this APU. There's lots of important traces going right here between the RAM and the APU, and we want to make sure not to damage any of those, and we want to make sure to not damage the APU either. So just make sure when you line up your precision cutters like this that you are not pressing onto the PCB and that you are really just cutting exactly where you want. You can go really slow with the cut to make sure that you cut in the place you want. So that's perfect, just like that. And we're gonna move on to the other corner here. And we're gonna do the same thing. I'm just going to line it up, go slow, and snip. And there we go, that's perfect. Just make sure it clears. And that is a perfect cut on either side. And I find that the best way to bend this off is to use both of your thumbnails at once. You wanna evenly put pressure across the whole thing and press upwards like this, and it's gonna bend it up. This sometimes just happens when you're cutting off the shield, where this point where the shield is soldered to the board will kind of just pull off. This is not a problem, it's just ground anyways. So we're just going to pull this whole thing back up, and we're just gonna bend this middle and left point off. So there we go. Keep in mind that when you bend it back and forth like that, you're gonna have some metal shavings, and you don't want those to go under the APU. So I'm gonna tilt the board up so they go this way, and we're just gonna kind of clean it off with a Q-tip and some alcohol. I'm actually pretty surprised that this one pulled up. Usually it takes a lot more for that ground pad to be pulled up, but it's not a problem. We can just cover this in some solder mask. So now what we're gonna do is we're going to zoom into this point here. And this point here is one of the reasons you really need a microscope for this installation. This via here is way smaller than you would think. So this is the via here that we need to solder to. And then this here around it is ground. So we don't want to scrape any of the conformal coating off of this area. If we accidentally do scrape any of this, it's not a problem. We just want to make sure to cover it in solder mask so that it doesn't short to this point here. So the best way to scrape this point back is to take these super sharp titanium tweezers. I'll have a link for these in the description. This is a great way to be very precise in scraping back points like this. I also love these for trace repair and that kind of thing. I do not recommend using the grinding pen for this, and I'll show you why. The sharpest tip for the grinding pen here is about the exact same size as the via, and it's really easy to expose the ground inadvertently when you're using the grinding pen, especially when it's rotating really fast. It's hard to be very precise with this on this fragile point here. I've also gotten boards where someone has dug this point fully out, and I've had to repair the trace between here and the via here. So I don't recommend the grinding pen. I don't think it's necessary for this kind of point. So when you're doing this, make sure that you have both of your hands fully on the table. And I recommend pinching one side of the tweezer like this, and then take your middle finger, put it against the tweezer, and then your thumb of your other hand and put it on the other side. And by doing this, you have lots of anchor points, and you can be really, really precise with where you're scraping. So we're gonna go back under the microscope. I'm just going to start scraping right over this via here. And it doesn't take much. You don't really need to put a lot of pressure. Just be patient and scrape back the via. I like to scrape a little bit up the trace here just to make it so it's a nice big pad that we can solder to. Clean as you go if you need to, just to see what you're doing. And that is plenty, just like that. So I'm just gonna take a Q-tip with some alcohol, and that's perfect. That's all we need. So next, I'm just gonna take my knife tip here. We can just use the point of the knife tip, and I'm gonna put some flux on that point, just like that. And I'm just gonna tin my iron and set my iron to 375 degrees Celsius. And you can just kind of scrape at the point a little bit, and then it will kind of be tinned like that. You don't have to scrape too much, just a little bit to flatten out the pad there so that solder sticks nicely to the pad. So sorry for the glare there, but that's perfect, just like that. And to clean the flux, we're just gonna use some low temperature hot air, like 160 degree hot air. And I'm just gonna heat up the flux, try not to blow it under the APU, and I'll use the brush and a Kim wipe just to clean it up. So that tinned up point right there is perfect, just like that. But while we're here, I'll just go ahead and add some solder mask to this area here. All right, so that's nice and cured and is not going to get in the way of our point there. And we also haven't exposed any of the copper around that point near the ground area. I think that bit of scraping is just from my soldering iron because I refused to put a smaller tip on, but that's totally fine. So there's two main ways to get to the .0 point. One is to dig through a couple layers of the board right here to solder directly to the .0 point with a wire, and this is the most reliable and robust method to get the .0 point. However, it does take quite a bit of skill with a grinding pen and experience with digging into multiple layers of a PCB. If you do not have experience with a grinding pen and trace repair, I highly recommend you do not do this method, and instead I recommend you use the .0 adapter, which you are going to slide underneath the eMMC module, which is right under this shield on the back of the board. This shield comes up a lot easier than the APU shield on the front. This is the internal storage or NAND chip of the console. And using that .0 adapter and sliding it underneath this chip is a significantly easier method to getting that .0 point. You just need to do it correctly in order for it to last a long time. So on this console, I'm going to be doing the Kamikaze method, but I'm going to cut to a video of me showing you how to properly install the .0 adapter if you want to do it in that way. Please use the .0 adapter method if you are not comfortable digging into the board with the grinding pen. If you do it correctly, it is still a reliable method for getting the .0 point. You just need to anchor all 4 of those points correctly like I show you here in this video. Okay, so for the .0 adapter method, you're just going to take off the shielding from the NAND on the back of the console here. And then similar to the APU shield, you're just going to cut here and here in the corners using some angled cutters like this, the precision ones. And then you're just going to bend it back and forth with your thumb, just like the APU shield, and clean it. And then grab your .0 adapter. This is the exact kind you want, because it has 4 anchor points, and you're going to slot it under the NAND just like this, and you want to line it up with the outline here perfectly. So push it back and forth until you get it into sort of the right place, and you also want to make sure your adapter is clean, at least on this part here, which is going to touch this solder ball. So this part here, which has this pad coming to it, is going to go pretty far underneath the NAND here and make contact with the .0 point underneath. Get it as centered as possible, and you should sort of see it rock back and forth if you push a little downwards towards the chip, and that lets you know that you're on the solder ball. But to double check this, we're just going to go into diode mode on the multimeter. Put your red probe on ground, and you could read up here on the top left where it says open. We get 0.4 voltage drop, which confirms that we're connected to the correct point. Now the trick with the adapter like this is that you need to apply pressure towards the chip with some pointed tweezers like this while you anchor all of the solder points. And we really want to be pushing down in this corner here, right above where it's making contact with the solder ball. So push sort of down towards the chip like this with your tweezers. You can't see really the pressure I'm putting, but I'm pushing down this way. So I'm going to tin my iron. You really don't want to use a ton of flux here. You want to use just enough, and you want to make sure it doesn't get under the chip. So that's plenty. I have my iron tinned, and I'm just going to take my tweezers in the corner here. Again, apply pressure downwards towards the NAND, and then only then apply solder to both of these points while putting that downward pressure. And right away, what we're going to do is I'm not going to use alcohol to clean this flux yet, because I don't want it to go under the chip. I want to get it away from the chip. So I'm just going to wipe it away with a dry Q-tip away from the NAND. And now we can use some alcohol to clean it off. Just going to brush it off away from the chip and soak it up. So there we go, nice and clean and properly soldered. And then we want to solder these extra anchor points here. And similar thing here, we just want to use a tiny bit of flux. So put some on your tweezers and pop it right where we want to solder, right there. And we just want to put enough solder between the point and the cap right there. So that's good. That's a nice anchor point. And once you have solder on there, just push downwards again with your tweezers in that same spot and reflow that joint. Just like that, because you want the pressure downwards as you're soldering the point. You really want to use as little flux as possible here, because if you use too much over time, it can just sort of get between the adapter and the solder ball and you have some problems. And again, a little bit of flux on your tweezers and put it down in this corner here, and then we'll come in and add some solder to the cap / pad next to it, just like that. That's perfect. And again, we're going to put pressure down on this while we reflow this joint here. Cool, that is looking great. So now I'm just going to clean the whole area as much as possible. I'm gonna use some low temperature hot air, clean this all up here. So once this is on here, you're gonna double check with diode mode, red on ground, black on the point. You can see we're at 0.399 or about 0.4, just where we were at before. So this is good. So last thing we need to do is solder to this little pad here. So again, I'll put a small dot of flux, just enough on that point. And you can see I have some enameled wire here that's already tinned. So you're just gonna take some enameled wire, tin your iron, get that point tinned, and then solder it to the pad. Looks like we need a dot more of flux there. Again, really try to use flux sparingly as best you can here, because you really don't want flux going underneath the chip. Gonna grab a dry Q-tip again and just wipe it away, and then we'll just wipe away any of the excess and soak it up with the Kim wipe. Great, so this is a beautifully installed .0 adapter. The reason these often fail for people is one of two things, or a combination of them. Either they don't put enough pressure towards the chip while soldering all of the anchor points, or there's too much flux used in the area and it gets in between the solder ball and the point on the .0 adapter and prevents good enough connection. And if you do use the .0 adapter like this, you need to run your enameled wire around this corner close to the NAND, and don't run it around here or here, because this is the shortest path over to the flex cable that you need to solder it to, which is right here. So you're just going to solder it right here where it says C. Don't pull it too tight so that you're not pulling that .0 adapter out from underneath. Make sure it has a bit of slack, but you want this to be as short as possible, because if you make this wire too long, you can have slow eMMC issues when you go to boot the console. And then you just need to bend the top left corner like this, so when you put it back on, it's not digging into your enameled wire and shorting it to ground. That's another reason these would fail, is if this just shorts to ground, you're gonna have problems. So give it a little window to the enameled wire just like that. The other thing you want to make sure of here is that none of the enamel is burnt off of this area, which is just touching ground. So make sure it's only tinned where it's attached to the adapter and not around this area. So this is a perfectly valid approach to the .0 point as long as you install the adapter correctly. But the Kamikaze method is a little bit more preferred since you're actually soldering directly to the .0 point. That being said, I have had a lot of success with this approach. Okay, thank you, Past Zach, for that explanation. For those of you who are brave, I'm going to show you a good method for getting the .0 point on this side of the board that you can solder directly to. I do not recommend you reflow the .0 adapter or unsolder the eMMC and solder a wire directly to the point under the eMMC. These are both unreliable methods which will eventually crack the solder ball underneath the eMMC, and then you'll have a console that won't even boot as a whole. So again, for this method, we're going to be using the sharpest tip on the MAANT D2 grinding pen. I'll have a link for this grinding pen in the description. And what we need to do is zoom in to this part of the motherboard. So what I'm going to do is just take a little X-Acto knife here and scrape exactly where we want to grind. So we're going to want to grind here. We're also going to want to grind right up until this other trace. You don't want to cut through this trace because it has an important connection here on this resistor. So do make sure that you don't cut through this trace here. We're going to grind right up until here, and we're going to grind right here as well. So you really want to use the sharpest tip you have here, because any of the other tips are going to be far too big for this sort of work. So get the sharpest tip that comes with this grinding pen. And again with this, we're going to do the exact same thing we did with the tweezers. We're going to anchor our hands on the table and use both hands to guide the tip of the grinding pen. If you use both hands like this, your hands will be super steady, and you won't have to worry about shaking around or hovering over like this. This is definitely not the way to do this. You're going to tear through the board. So definitely anchor both of your hands on the table and use both of your hands anchored on the grinding pen. And then you'll have lots and lots of control over where exactly you're putting the tip of your grinding pen. So before we start grinding, I highly recommend just putting a little dab of flux on this area. And this is just going to help sort of collect the dust that builds up as you grind so it doesn't go flying all over the board, because we are going to be digging into conductive layers. So I'm going to turn my grinding pen on to the lowest setting. Again, just anchoring my hands, and I'm going to start grinding just in this square here. All right, and this is a great place to stop and just wipe up what you have grinded already with a Q-tip and reassess. So I need to grind a little bit to the right more. So I'm going to put some flux back on here because we need to grind a little bit further to the right. And don't go deep, just do enough to take off the very first layer of the conformal coating, just like this. So now we're going to just keep going until we hit the first layer where we don't see any more copper. So I'm just going to go on the perimeter here, and you can see we're starting to hit a layer where there is no more copper. So that's good. We're going to stop there, and I'm just going to clean up what we have here already, just so I can show you exactly what I mean. So this is perfect, just like this. So we want to do one layer at a time, and we don't want to dig too far into the PCB. If you just sort of go at it, you're going to end up digging through multiple layers of the PCB at once without realizing it. So this is perfect. You can see we're being very controlled with how many layers we're taking off at once. We took off this top green area, which is exposing this ground pad. And then we're going to take off the rest of this ground pad to expose the substrate underneath. So we don't want to yet go further than this substrate area here that's not copper looking. So I'm going to do the rest of this to make it look the same as this, and we'll continue. I'm digging a perimeter on the outside of this rectangle here, right up until the substrate, and we're just going to clear the center part of this area here. All right, again, just going to clean. Just want to soak up all of that dust. Cleaning as we go is ideal. All right, we can start seeing the next layer of copper here under the substrate. So I'm going to dig a perimeter again around this, and we're going to take off the substrate to expose the next layer. So again, we're just going to go one layer at a time. Perfect. So let me just clean up. So now I'm going to dig through this layer of ground. We do need to go right up until this sort of trace right here. So I am going to dig a little bit more just on the right hand side right here. This is perfect. And I'm going to go a little bit deeper, just like that. That's perfect. And we're going to start doing that around the perimeter of the entire area. So I'm just going to go one layer deeper now around the whole thing, just like this. You can see the next layer is coming through. We're not rushing it. We're just going very slowly, doing one layer at a time. So I'm just going to get rid of this middle area here, and we will pick up from there once the rest of this is off. I can't stress how lightly I'm pressing with the grinding pen on the board. It really does not take much, so you just want to do really, really light taps like I'm doing here. That is perfect. Okay, so we've successfully dug through the first two layers of the PCB, and we're starting to see outlines of the next layer. If you use a little bit of alcohol, I'll just dump a tiny bit on here so we can look. You can see the dot 0 point. The dot 0 point is right here. You can see that little circle right there. That's the dot 0 point. So all we want to expose is this little circle right here. We can also use UV light. UV light is a great way to look through substrate, and you can see perfectly. Look at that. It's pretty cool. So that top point there is the one we're looking for, not the bottom one, but the top one closer to that A point resistor. So hopefully without the UV light, you can begin to kind of see the point that we need to dig, especially if we use some alcohol. It's the final stretch here, and I'm just going to try to expose just that one point, just like that. That's all we need. No need to go too crazy with this. We just need that little dot 0 point. So you can see with lots of patience and just taking it one layer at a time, it's really not too difficult to get that dot 0 point exposed. You definitely have to take it slow, and you have to have experience using your grinding pen and know how much pressure to put on the PCB to dig through a layer at a time like this. One of the really important things I want to point out here is that this exposed trace here on this side of the resistor is not touching the ground plane underneath it. And we can double check that by using resistance mode on our multimeter. So I'm going to use ground on the black probe of my multimeter here, and we should definitely not have continuity between those two. So you can see on the top left we have 2.5 kiloohms. That's good. So the only reason I say that is because when you're grinding, it's easy to accidentally touch the two layers here together. These over here don't matter too much because this is ground and this is ground, but these two here do matter. So you want to make sure this trace is not touching the ground layer underneath it. And what I'm going to do now is take a X-Acto like this. I like to use this Fiskars little anchoring X-Acto because it lets you anchor it to your finger, and you can be very, very precise with where it is. And I'm just going to squeeze out a nice chunk of solder mask and put it at the tip of my X-Acto like that. And we can go over here to the microscope, and we're just going to kind of use this as a little pool to dip our tweezers in. Here, let me see if I can get this in focus. So I'm just going to dip my tweezer in like this, and that will make it so that when we go down to this layer and put some on, that it makes it nice and thin. You don't want your solder mask to be put on in thick layers because it won't cure properly. It will only cure like the outside of it. So we're just going to go around and put mask on all of these points here where we don't want to solder to. So I'm just going to continuously dip my tweezers into the solder mask that I have on my X-Acto, and we're simply going around and depositing it onto the areas that we don't want to solder to. It's fine if it covers it like that. We can always scrape it back after the fact. So that's plenty solder mask, just like that. And as always, I like to cure it for 1 minute, clean, and then cure for 1 minute. So we'll wait for this to finish up. All right, so the 1 minute is up, and I'm just gonna come in with some alcohol and a Q-tip and clean it up so it gets nice and dull, just like that. And we're gonna do 1 more minute. Perfect, so that finished curing, and we can just take our tweezers, just like we did to scrape off the clock point, and I'm just gonna scrape the solder mask away from where we want to solder to. Some alcohol, and this is looking pretty solid. So when I was scraping, I did take a little bit of solder mask away from this little trace here, so I'm going to put a tiny bit of mask over that, and at the same time we're going to cover around the point here as well. So we want to cover this whole substrate area here. So I'm just going to take a little bit more of the solder mask, and we're just going to pop it down right on top of the substrate there, like that. That is perfect, and I'll go ahead and cure this as well. So that is a beautifully exposed that 0 point right there, and I'm going to use my red probe on ground in diode mode, and we're just going to check that point, and we should get around 0.4 voltage drop there, which we are getting, and that's looking great. So now we have to tin that point and solder to it. So I will just kind of do the same trick I did with the via and scrape a little bit on the pad. By the way, I'm using the bent conical tip now. I'm not using the knife tip. It's a little bit too big for this area, and you can see this is nice and tinned now. I'll put a little bit more solder paste on there. That's plenty, and again some hot air, and I'll boost it up to like 375 here. We can add a little bit of flux, and you can see there it went nicely directly onto the pad. That's exactly what we're looking for. So we can give it a little bit to cool off. So now I'm just going to cut a bit of nice length 38 gauge wire here. I know I said 30 gauge in the beginning of the video, but the 38 gauge here is much better suited for this particular point. And I'm going to set my iron to 425 because we need to burn some of that enamel off of the wire. So I'm just going to try to tin the end of it just like that. And now I can adjust the iron back down to about 375. And I'll use my snips here to just cut like a tiny bit off the end of that wire because we don't need that much tinned. I just want the very end of it tinned just like that. So I'm going to use 2 pairs of tweezers here to line up the wire perfectly, just like this. I'm going to add some flux. I added more flux to my tweezers there than the actual point. Obviously that's way too much, but can't really do much at this scale about that. And I'm going to come in with my iron and solder that down. That right there is perfect, and I'm going to go ahead and get this cleaned up with some alcohol. So now that this delicate point here is nice and soldered, we want to cover the whole thing in UV mask. We're just going to come in and use my tweezers to deposit solder mask in a nice thin layer. We just want to insulate this and also provide it with a little bit of structural support. We'll stick with that, and I'm going to cure that. Then I'll just hit this with some alcohol here, and we're going to add more solder mask, and we're going to kind of want to route this downwards a little bit, and you'll see why when we put the flex cable on for the other points. But for now I'm just going to kind of route this downwards, and I'm going to go ahead and cure that as well. And I've tinned the bit of the wire here at the end, and if I put my red probe on ground and my black probe on the wire, you can see we're making a great connection with that point. We've got that same 0.4-ish voltage drop right there. So that's great. So this is looking really nice. Now we're going to take care of installing this flex cable here. So this is going to line up just like this. You can see this D point is going to connect to the via that we exposed. This point right here is just to sort of anchor this part of the flex down so it doesn't go anywhere and rip up the via. And then we have this A point that we need to solder on this side of the resistor here. We have some ground points we can solder. And then we have the 3.3 volt point up here on the capacitors. I'll just note really quick here that if you bridge these two caps here while soldering this, it's not a big deal because both of these caps on this side are the same point. So no stress there if you bridge them. The other thing I'm going to do here is I'm going to pull this wire around underneath the flex cable because we want that 0 point to be as short as we can get it. And it's going to need to go right over to this C point right here. All right, I'm gonna set my iron to 375. I'm gonna tin up the iron, and we're going to put some flux on a few of these points here. So I'm gonna put some flux on the ground areas over here. Just find that it moves. We'll move it back in a second. I'm gonna put some on the A point, on the C point area there, and then over here. Not being very precise with this, but it's really not a big deal. And then on the 3.3 volts area here. So we've got flux in the areas that we need it, and I'm gonna realign carefully the flex cable here. And we really want to make sure that this lines up nicely with the clock point right here. So I'm just going to solder that first actually. So you can tin these points first if you want. It can make it a little bit easier. So that's nice and soldered there. And we can also solder this resistor here to make it a little bit more secured down so that doesn't go anywhere. And for the rest of these points, I actually will switch to my knife tip because I prefer the knife tip for these types of points here. Even though it is a bit larger, it does make soldering a little bit easier. Just be aware with this A point that it's very heat sensitive. So you don't want to leave heat with your iron on this A point for a long period of time. You just want to sort of tap it enough to solder it to the resistor. So if you heat that resistor for too long, it's going to cause issues just like that. That's plenty. We're going to leave that alone. If after your installation you have a purple screen, it's almost definitely going to be this A resistor here. You would have to take this off and replace it with a 4.7 kilo ohm resistor. It really doesn't take a lot to kill that resistor, so just make sure you don't put heat on that resistor for a long period of time. So now we're going to come up here to the 3.3 volts. We're going to have to use tweezers to put pressure down on the flex cable, and we're just going to get that guy soldered up. That looks beautiful. And finally, we want to solder these ground points. As with all the other points and with soldering in general, you want to apply heat to both the pad and the thing that you're trying to solder to. So we're going to heat up the shield and leave our iron on here for a little bit longer than usual. And this is going to allow the solder to adhere to the actual shielding, just like that. So I'm just going to have to tin my iron a little bit more. And we're going to do the exact same thing here. Just put heat on both the shield and on the point there. We have a bit of extra solder here we can take off. We can also just come in with some wick at 425 and just sort of snag all of that off of the shield so we don't have to worry about it. And then lastly, we want to tin up this C point here, and we want to line up our wire so that it is as short as we can manage. So I'm just going to go ahead and cut it right here, and we can get this soldered to our point here. So to burn the enamel off at the same time, I'll use 425 to just make sure that does get properly soldered to the point, and that is looking good there. Cool. So all of these points are looking really nice. I'm just going to take some low temperature hot air at about 160 to 170 degrees Celsius and 65% airspeed here. And I'm just going to hit up this whole area to sort of liquefy the flux as best I can. And then I'll come in with a Kim wipe and some alcohol and do my best to clean it all up. Maybe we can also try one of these little cleaning foam cubes. Just gonna squeeze it a few times over this area, and then we should get it nice and clean. Cool, so that did a pretty decent job actually. Oh, and I just noticed right here that we have to clean up whatever's going on here. So let's go ahead and do that. Let me just snag that bit of solder. Cool, so these points are looking really good, and I'm just going to use my meter and diode mode here and measure each of these points. So we've got 0.39 clock, which is good. We've got 0.39 on the -0 point, which is good. 0.4 on command, 0.47 on 3v3, which is great. So these are all looking really solid. So we can move on to the CPU flex cable. So I'm just going to clean up here one more time really quick before we get started. Just making sure those caps are nice and clean before we solder to them. So for the CPU flex cable, we're going to be lining this up just like this, but don't solder it right away. We're just going to route the flex cable underneath this little metal shielding here. And we want to clear the MOSFETs with this metal backing here underneath this shielding. And then you also want to make sure these little tabs go underneath the shielding as well. And then we can line it up. I don't necessarily recommend tinning these flex cables before you put them on. I know a lot of people like to do that. But in my experience, these aren't always cut super well. And when you tin them, it makes it harder to flex them around the caps. In this case, this one's actually cut pretty well, so it's not a problem. But that's just my 2 cents. So I'm just going to throw some flux on the 2 capacitors here, as well as on the 2 grounding points. And really, we're only looking for 3 points with this flex cable. We're looking for the 2 inner points, and then we're looking for at least 1 ground. I'm going to solder all of these here, but I just want to point out that we only really need technically the 2 inner points and ground. So I'm going to tin my iron here, and the key with this flex cable is to press down on it with tweezers while you're soldering it. And we also want to heat the capacitor and the pad at the same time. So you don't want to just heat the pad or just the capacitor. We want to do both, just like this, and we can move up and down a little bit. That's exactly what you want. You want the solder to overlap on the actual cap. You don't want it to just be sort of on the pad alone or on the cap alone. You want it to be overlapping, just like that. That looks great. So I'm going to clean my iron, and we're going to do the exact same thing on this other side here. I'm going to press downwards like that. That's great. And we're going to do the other side. And that's a great example of where I'm not applying heat to the cap and the pad. You can see it's not fully connected like it is on the other side of it. So we want to make sure that it is going fully onto the cap, just like that. That looks great. And I was using 375 for that. I'm going to boost my iron up to 425 to solder these ground points. So again, we're going to heat the shield at the same time as heating the pad, and you can kind of go back and forth like that to make sure the solder sticks. And you don't want to use too much solder here, because if you use too much, it's going to bubble up a little bit too much and cause problems for the shield going back on. I'm actually going to take a little bit off of this here because it is a little bit higher up than I'd want it to be. So this flex cable is looking really nice. I'm going to heat the area with low temperature hot air. We're going to use 160 degrees Celsius hot air to liquefy the flux. And you can use a Q-tip if you want. I'm just going to use this foam cube here. We can even dab it while applying heat. And you really want to try to press out as much of the flux from underneath that flex cable as you can. So that's why I like using the foam cube here or a Q-tip to just press the flux out from underneath the flex cable. I just recently found these foam cubes, and I'm really finding them great for applying pressure while absorbing flux and alcohol. They really do a great job. All right, and I noticed we have some like nastiness right in between these 2 points. I don't know what the hell that is, but we're gonna try to get that out of there. Looks like an extra bit of solder or burnt flux or something. And this is exactly how you want your APU flex to look, with the solder overlapping on each of the caps, just like that, and fully adhered to the pads. And we have it nice and anchored down here with these ground points. Again, I'll reiterate that these 2 inner points are the actual SP1 and SP2 points. The outer points here are just ground, and we can measure that with the multimeter. So we're going to go into resistance mode, and measuring between ground and the inner point, we should get a low resistance, 11 ohms, 12 ohms. Your multimeter might beep, but don't be afraid. This is not a short. This is what it's supposed to look like. The APU is low impedance, so you're going to get a low ohm reading there. And then here, this is going to be ground. You can see that's like under 1 ohm. So this is just ground. These 2 are connected here. And with the flex cable, these 2 are also connected on the inner side. So that area is nice and clean. And we're going to take some Kapton tape like this. I'm going to take my ceramic scissors and cut a nice sized piece of Kapton tape like this. And I'm going to cut it in half down the middle. And we really just need like this much right there. And I just like to line the straight side of the Kapton tape up with the die, just like this. And then we can place it down and just press it into place. And this is going to insulate those points from the shield that we're going to put back over it. And speaking of the shield, we actually need to bend the shield up a little bit with some needle nose pliers. And we're going to need to bend it in a couple areas. So we're going to need to bend it over here to make room for this flex cable. So we're going to have to bend this lock. And then moving up here, we have to make room for these ground points here. So we have to bend the middle lock here and the 2 tabs on either side. So I'm going to be bending this and then this and this. So these 3 middle tabs here I'm going to bend in, and that will just make room for the solder that we added to this ground point. And we also need to make room for this point so it doesn't touch the shield. So we have to bend in these 3 points right here, these 3 tabs that are going to be right above that clock point right there. So those are the main areas we're going to be bending in. So we got to bend in this bottom one here. So I'll bend that now. Just make sure it's nice and flat so it doesn't cut into that flex cable. And then we're going to bend the middle 3 on the top here. Again, just flattening these out so that the shield sits flat when we put it back on. And then these 3 in this corner here. As you can see, we have a little window here for the clock point, here for the ground points, and then here for the flex cable. All of the other locks are bent in and ready to be clipped on. So what I'm going to do is just clean up this die one more time with some alcohol and a Q-tip. Make it nice and shiny. Now we can take some thermal paste, pop a little dot on the center there. That is plenty. You do want to use a little bit more than you normally would here because the heatsink doesn't actually put all that much pressure down on the die. So we're kind of relying on my finger pressure to spread all that out. So I'm being a bit generous with thermal paste just to make sure it does cover the entire die when I put pressure down on the shield. So I'm going to line up the shield here and just put pressure down on the center. Make sure that thermal paste spreads out nice and evenly. And then we can come around here. We can make sure this is lined up with that little window and click it in. And we can clip in all of these corners and the locks. And you can see right here why we want to bend the shield there, because we don't want it to touch that clock point. Then we can also clip this in here. So the last point we're going to need to deal with is the B point, or the reset point, which is right on the other side of this speaker connector here. If you flip the board at the bottom of the board here, it's going to be this point right here, right next to this little triangle. So I'm going to cut some 30 gauge wire here, and I'm going to set my iron to 425 in order to burn off the enamel. So I just tinned my iron up a bunch so we have a nice glob of solder on there. I'm just going to touch the wire to tin it, and now that it's tinned, we can cut the wire. And I like to route this through right here where the speaker wire goes, and that's exactly where I want it, right there. So I'm just going to grab a little bit of flux and we can solder that point on there. Perfect. Again, liquefy the flux with some low temperature hot air, and we can clean it up with a brush and a Kim wipe. And now I'm just going to kind of bend this underneath the PCB just like that, and I'll give it a final clean here, and that B point is looking great. So this is going to go to the other side of the board, and I like to try to route this onto the right side of that speaker connector there, because we don't want it to get in the way of the actual speaker cable. And this is a perfect area for it to come up and attach to the B point on the Picofly, which is going to be right there basically. So that's perfectly lined up, and we can kind of bend this out of the way for now and mount the Picofly now. So now I'm just going to take a Q-tip and clean this area of the shield, and you can see it's not perfectly flat because we've bent in some of those tabs there. And I like to use 3 to 4 layers of double-sided tape because it provides enough thickness to adhere to that uneven shield. So we're just going to grab 4 little bits of double-sided tape and just sort of attach them together like this. Then I'll just grab the Picofly and we'll line it up with the chip. It's a perfect thickness to fit on the back of the chip here. And then I'll take my ceramic scissors and just cut off that excess right there. Now we're going to undo the lock at the top of the Picofly here, and then fold over this flex cable, and then we just got to plug it in. Make sure it's all the way in the connector, and then lock it down just like that. And then I'm just going to line this up. Try to put it as much this way as you can, but don't put tension on that flex cable. And we're going to line it up with this flex cable here and press down. So that's nice and lined up, and we can make sure that that is adhered to the shield with the tape. And I like to just press down on this flex cable here too to sort of fold it. And that just sort of prevents it from trying to pull itself out. And then we're going to do the same thing with this flex cable here. We're going to unlock this lock here, bend it up, feed it into the connector there, lock it down, and then I'm going to push down to sort of fold it. You also want to make sure that this lock for the USB port is folded downwards and not upwards. And then we're going to come in here with the microscope and line up the B point wire here. So that's just going to go right like this. I'll just trim it right there. Again, 425 on the iron to just burn off the insulation and tin it. If you use too low temperature on this enameled wire, it's going to be difficult to tin. You can see it was effortless there. And now we can go down to 375. We can apply some flux on the B point and we can get the wire lined up. I always like to use 2 pairs of tweezers to line up wires like this, so you can make sure it's actually touching the chip and not just kind of floating above it. And I want to make sure to apply enough solder to actually tin the pad and connect the wire to it, just like that. Just going to liquefy this flux a little bit. I don't want to liquefy it too long because you can easily damage that boot button right there. Now we're just going to clean this area here. Cool, so this is looking really nice. And as a last step before we put this back on the console to test it, we're just going to check all of these points with diode mode. So I'll switch my meter to diode mode, and I'm going to put my red probe on ground, and we're going to put the black probe on 3v3 here. So we've got 0.36, it's looking good. Then we've got the D point or clock, that's 0.4, that's looking good as well. Then we've got the A point, 0.41 voltage drop, looking good, A or command, and then C, which is the .0 point, 0.4, also looking great, and then B, which is reset, and that is 0.38 voltage drop, that's good, and then we've got ground there, which is great. And we can also come down here and check the CPU point, which is 0.36 voltage drop, so that's looking good as well. So these points are all looking great, and I'm comfortable getting this plugged back into the rest of the console to test. So we can plug the battery in, and we're going to press the power button, which is the rightmost one here. You can use your nail to press it in, and we should see a bright white light here, and then a flashing blue one eventually. So we're seeing the flashing blue, and then we should get a final flash of white light, and we get our beautiful no SD card screen. So this is a perfectly well installed Picofly. If you press once on the power button, it will turn off again. So we're just going to try one more time. Should go a bit faster this time because it kind of learns this particular console. So that's good. And before we get everything reassembled, I always recommend pressing both volume buttons here. And this should boot into the official firmware. And you can see here it is booting into the official firmware, which is great. And get this thing turned off. Keep in mind, when you turn the console off from the official firmware, it will, after a little while, we're just going to wait here and I'll show you. It's going to resupply the 3.3 volts power rail to the console for some reason. And you can see it just turned on the chip there again. This only happens when you turn the console off from the official firmware. When you turn it off from Hecate or when you force shutdown, you won't see that happen. So just don't be alarmed if you see that happen. So we're going to go ahead and just unplug the battery now, because we need to do a couple more things to get this reassembled. The first thing we're going to do is grab this Kapton tape here, and I'm just going to take a few pieces, a little longer than the Picofly itself, and I'm just going to press this down onto the shield here, and this is just going to insulate it from the shield that we're putting on the back when we reassemble the console, because the shield is metal, and there actually is on the OLED enough space for the Picofly when you have this cover back on, because this part where the Picofly sits is raised up on the shield, and there is actually sufficient room to put this back on without having to modify the shield, unlike the other consoles. So I'm just going to put my last little bit of Kapton tape on there. Then we're just going to pop a little dot of thermal paste right in the middle there so we can put this heatsink back on. So we're just going to line this up, press downwards, and you can see now maybe why I mentioned to put this Picofly as much this way as we can. That's because we don't want this heatsink to press down on this chip. You should also be aware of the fact that this point that we just soldered to down here, this clock point, as well as the .0 point here, are both pretty close to the heatsink bracket here. So you just want to make sure that you have this perfectly lined up and it's not going to short any of those to ground. And this thing is fully reassembled. Just going to wipe the screen down a little bit here and we can boot it one more time. You can see it's working nicely. I hope you guys enjoyed this tutorial. This video took a good chunk of time to make. So if you guys are interested in microsoldering content or tool reviews or things like that, be sure to hit the subscribe button if you want to see future videos. But otherwise, thank you guys for watching, and I will see you in the next video. Peace.